Hello, right, welcome to this one. Now this one is what we call, let's get the pen, draw. This one is called, well, I'll call it velocity time graphs. Yeah, and it's all about calculating velocity, which is a speed in a given direction, velocity, and acceleration, and distance, and time, and all sorts of other things. Yeah, so let's go with this one. So let's draw some lines on here, and we'll just show you what a velocity time graph is, and not to get confused with distance time graphs. Yeah, so we've got something like that, and whether I can so what we can do, we do I don't know, 10, 20, 30, 40. We've got 6 of these graphs to look at for various aspects of what we need to do, and 80, and this is time, and we'll call it in seconds. It could be anything, meters, minutes, hours, anything. And this is velocity, and this is in meters per second. That's how fast we're going, yeah, that sort of thing. So let's do some numbers up here. 50, 60, 70, don't matter, yeah. Right, so with a velocity time graph, we have this sort of thing. This is what it looks like. So we're going to go I don't know, from there up to there, and then we're going to have a second part, which is going to be, say, that far, and then we'll have a third part, which will come back down to there, to the 80. Right. So what this tells us is that over time, we started off going no meters per second, and we ended up after 40 seconds ended up going 50 meters per second. So we've been accelerating, and we've been accelerating at a constant rate. And when we got to 50 meters per second, we maintained that speed for 20 seconds or so, and then we decelerated to come down the other side. Yeah, and so we could get a question of how far have we traveled? What is the distance? What is the distance? And this distance is the area under the graph, under the line of the graph. Yeah. So what we need to do now here is we need to just calculate all the area under the graph, and for that we would divide the shape, not into that, divide the shape into triangles and rectangles. Let's get rid of that bit and all these little dots here, and let's call it A, B, C, and we'll find the area of these three, and then we'll find out how many meters we have travelled. So A is going to be half base height, which equals a half times the base is 40 times the height, which is 50. 4, 5, 7, 20 to 2. Let's have a look. So, brain's gone bonkers. Half times 40 times 50 is 1,000. I should have been able to do that in my head, but just for a moment. So that's 1,000 meters. B will be equal to this, 20 times 50. 20 times 50. 2 5s are 10. That's also 1,000 meters. And C, half base height equals a half times the base is 20 and the height is 50. So that will be equal to 500. And all three together, 1, 2, 2,500. 2,500 meters. Yeah, total. So that's a velocity time where you're working out the distance traveled. Right, the next kind of question they can give you is, whilst I'm filling this all in, well, we're changing colours as we go along. Never mind. Let's do this. So we've got the time again, and we've got the velocity in meters per second, and this is in seconds. And so again, we do 10, 20, 30, 40, 50, 60, 70, and 10, 20, 30, 40, 50, 60, 70. So when you get one of these, immediately look to the left and see whether it says velocity or whether it says distance. Yeah, if it's distance, then it's just a distance time. If it's velocity, and we can ask the question of what's the speed? What's the speed at a certain point? And so we'll just do anything really up to there. What's there? It doesn't have to go up and down. It doesn't have to go up and down. Yeah, it doesn't have to go up and down. It can be anything. So what's the speed at 40 seconds? And what's the speed at 20 seconds? 20 seconds. So 40 seconds, what we're going to do here is you just go from 40 seconds there, go up till you hit the line, doesn't matter whether it's flat or not, and then go along, and the speed there is 40 meters per second. And at 20 seconds we go up there till we hit the line and go along there, and that looks about 24 meters per second. So that's the second. Now the third one is a little more complicated, and it is this. We have to work out acceleration, average acceleration. And again, we'll use the same thing, time in seconds, 10, 20, 30, 40, 50, 60, 70, 80. All this stuff's filled in for you, and velocity in meters per second, all filled in for you already on the exam, so you don't have to keep doing this over and over and over and over and over again. Yeah, so 80. Yeah, so what I'm going to do with this one is see whether I can actually 30. We're going to work out acceleration. Okay, so let's see whether I can draw. Go to there. Then I'm going to go up a bit. Yeah, going to go up to there, and then I'll come back down. Come back down. Okay. So at this point we are accelerating at two different rates, and here we are decelerating. So we can calculate an average acceleration. So we want an acceleration, an average acceleration for the first, what's that, 30 seconds. Now, acceleration is calculated by the change in y over the change in x. Right, so what you need to do is look at the first 30 seconds, which is here, which is up there, yeah? So the change in y is from 0 to 50. The change in x is from 10 to 30. So 50 divided by 30 is 5/3, obviously, so it's 1.6. 1.6 recurring meters per second. Probably meters per second squared, but this is acceleration. So it may be counterintuitive that we've gone from 0 to 50. So why isn't it like 25 or something like this? Yeah. So this is just calculating the acceleration. So we've gone from 0 and it's taken us 30 seconds to get to 50. So every second we've done an average of 1.6 meters per second acceleration. Yeah, we are accelerating. Now you can get on the same kind of thing is where you would be asked to work out the average speed for the first 30 seconds. Yeah, now this is a different, so for working out speed we need this don't we? Speed, distance, time. So we know that the speed is equal to the distance over the time. We know that the time is 30 seconds, but the distance is calculated by the area under the graph, which is half base times height. So this is half base height. Well, now half base height is half times 30, so a half times 30 times the height is 50. So that comes out as 0.5 times 30 times 50, which is equal to 750. So we've got 750 divided by 30, and that looks like it's going to be 25 meters per second. Yeah, so that's the average speed. Yeah, which is fair enough, isn't it? Yeah, because we got to 50, we started from 0, so 25 will be halfway up, so that's the average speed, not to be confused with the acceleration. Yeah, I think that's per meter second square. I'm not too sure on that, but the acceleration and the speed is something different. So let's do the come back. Right. So if we have another one here, I don't think we need to. Yeah. Yeah. Let's do another one there and go there. Again, we've got the time. Nearly put speed there, didn't I? The time, and here we've got the velocity. And let's make the numbers easier. 1, 2, 3, 4, 5, 6, 7. Okay, and we're just going to have a random line, yeah, for this just to explain this. So we're going to go from there, right? So we're going to work out the average acceleration and the average speed. Okay, the acceleration is done by the change in y. The gradient is what we're working out here, isn't it? The change in x. Now, so the change in y is 6, the change in x is 8, so that equals 3/4 of a meter per second. the acceleration. The average speed, we have to work out the area underneath the thing, which is, first of all, we do half base height, which is half times 8 times 6. 6 8s are 48, 24. And the speed is equal to the distance over the time, which is 24 over 8, which is equal to 3 meters per second. Yeah, or I don't know why I'm putting that on there. It might be true. It might be true. It might be true. So far, all these have had straight lines. Now, I'm going to move up to, I think it's grade 9, this stuff, or grade 8. Yeah. So it's not the easiest thing in the world, but it's not bad. It's not bad. So we've got the time, and we've got the velocity in meters per second. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and the time is in seconds. Of course, this might not be if the numbers I'm putting on the side are a bit simple, so look out for this. So it might be that we've got something like this, yeah, and it's a curved graph, and we're gonna have to work out the distance. Now the distance is the area under the graph, but this could be a nightmare, couldn't it? So what we do is we just do this, and we'll make straight lines out of the things, yeah? And we'll make straight lines there. And we'll make 2 triangles so that we can possibly work out these triangles. So we've got triangle A and triangle B, and this is all we do. We just smooth out the lines. So the distance A is half base height, which equals a half times 6 times 7. 6 7s are 42, and half that is 21. And area B is the same, half base height, which equals a half times B is the base of that is 2, and the height is 7. So that's 2 times 7 is 14, 7. So add the 2 together, and 28 meters is the distance. That's how you work out the distance under a curved graph. And the very final thing we've got for this offering of vectors, not vectors, is it? What am I doing? It's velocity time graphs. That's the problem with this GCSE. There's so much involved. Time in seconds and velocity in meters per second. Now, you might have to work out like this, yeah. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. You might have to work out the average. Let's have a look. The average acceleration. Average acceleration. Overall, yeah? Overall. So we know that the average acceleration is the change in y over the change in x. The change in y is 7.5, and the change in x is 8.5. Okay, so that is for the whole line. 7.5 divided by 8.5. So, or 0.88 meters per second, probably squared. Yeah, so you can do that, and you can work out the average speed by making a triangle there, something like that. Yeah, and so that will be half base height because we need the area, so this will be equal to half times the base, which is 8, times the height, well, 8.5, sorry, 8.5 8.5 times 7.5. So it's 0.5 times 8.5 times 7.5 equals, and 31.875 meters per second. Yeah? Oh no. No. 31. That's the area of that triangle, isn't it? Yeah. Gosh. Yeah. So we now need speed equals distance. So that's the distance over time, which is 31.875 divided by the time, that's 8.5. Divided by 8.5 is 3.75. 3.75 meters per second. Right, so now the only other thing that they can ask you on this is they will say, what is the speed? What is the speed at, we'll say, 3 seconds. Yeah. So you can go up to the 3 seconds and then go across there, and you can say answer 5 meters per second. And then they might say, what's the acceleration at 3 seconds? Okay. Now, we can do the acceleration is done by the change in y over the change in x. But at 3 seconds there, we haven't got any changes because it's a specific point. So what we need to do here is draw a tangent. And draw a tangent as more or less best as you can do. So you draw a tangent so that you can have a change in y and a change in x. So you don't have to go from the beginning to the end of the line, it doesn't make any difference, but I will. So the change in y from here up to the end of the line is there, so that's 8.5. So the change in y over the change in x. So from 3 to 8.5 is 5.5. And from here, which is 0.5, to all the way over here, which is 7.5, is 7. So the acceleration at 3 seconds is 5.5 divided by 7, which equals 0.7, call it 0.79, 0.79, yeah, meters per second acceleration. And that's the way to do it. Acceleration is done by the change in x and y, and the speed is done by working out the area so that you can use the speed distance time triangle. Anything else on there? No, so remember to draw a tangent. Oh, and one other thing is when I worked out the area under the graph, because I straightened all the lines out, I actually missed out all that. Yeah, so my calculation for the speed, which used the area, is an underestimate. I might ask you that. Is your answer over or underestimate or overestimate? And that is that one for Venn diagram. No, it's not. What is it? It's velocity time graphs.